So today we will learn about differentiability and continuity. So first I would like to thank Mr. Bean, Mr. Sullivan, Mr. Burts and Mr. Kelly for using their resources. So we have been graph of a function is given to us over here. So first thing we have to do is we have to write the equation of line over here. So let's write the equation of line. So when I'm writing the equation of line, first thing which comes in, some of you might have forgotten how to write the equation of line. That's so simply what we are trying to write is y is equal to mx plus b, where m is your slope and b is a y-intercept. Y-intercept means what? Y-intercept means value of y when x is 0. So when you look over here, value of y when x is 0 over here. What is the value of y? You will see over here somewhere, this is 1. So your answer will be what? Y is equal to plus b is your 1 over here. Now what about your m? M is your slope. How do you find your slope? Slope is yours rise over run. So what you do, from this point you can rise over here. I can go over here 1, 2, and I'm just taking this point over here. So I went over here, rise 2 points, and I ran to the right 1. So it's my what? 2x plus 1. So I ended up with this equation of line over here. So this is the equation of line over here. But what if I am showing you this graph does not look like this? If I am zoom in and I can see my graph looks like this. Let me show you if my graph looks like this. So see, if you over here see, if I zoom in, you see I'm getting bigger and bigger over here. So let's see. So you see when I'm zooming in, you can see it's just going big, getting bigger and bigger. We are just going over here. You can see these remaining points over here. So what if I'm asking you what is the slope of the line over here? So you will say, Mr. Gupta, I can still give you the slope of the line over here. It's not a problem. Again, it will be what? Y is equal to mx plus b. So what is your b? B is in this case is what? Now if you look over here, because I changed the scales over here. Now in the first picture, what was given to us is, let me bring the first picture over here. In the first picture, I didn't give you any of these. See, you see these, I did not give you what are these numbers over here, 1, 2 and 3. I did not give you the scale. Okay, so if I say the scale was not like this, scale was like this, I give you some numbers over here. Now in this situation, what happens is, now you have to find the equation of line. So if you do equation of line over here, again y is equal to mx plus b. So I write over here y is equal to, let me pick my pen, y is equal to mx plus b. So what is my b over here? Now b is what? Value of y when x is 0. So what is this y value over here? If you see 0.003, this means it will be what? 0.001. So this is what? 0.001. What about the m? M is your rise over run. So you went 2 points up and you ran to the right. Now do keep in mind this point has what? Changed over here. This is 0.001. So this has been changed. So what will be our answer over here? Our answer will still be the same. Rise is what? 0.002. And what is your run? Run is your 0.001. So rise over run, when you will do it, you will end up with what? You will end up with 2, and that's your answer over here. So we got second also if you zoom in. So I will come back over and write it over here. It will be y is equal to 2x plus 0.001. Okay, now what happens is, if I keep on zooming in over here, or let's say if I zoom out, what happens when I zoom out? You see over here, see what was given to us, we were given only a straight line over here. I'm just trying to do, here you go. We were given a straight line over here. Now if you can see what is going on is, actually it was given to us like this. Let me use this over here, hold on. Here you go. So here you go. So what we were given only a part of this whole graph over here. See, we were just given only a part over. You see this part was given to us. This part was given to us. But if I was zoom in, what I can see is it's really a curve over here. So what is this? This is a sinusoidal wave over here. Actually, it is a sinusoidal wave. If I keep on zooming in over here, what I will see it was like this. So what I'm trying to tell you is, in this, look over here. So here you go. So it looks like this over here. All right. So now let's talk about our differentiability. What is differentiability? Differentiability is the process of finding the derivatives of the given function. Okay, there are some rules which we have to follow, which I will be explaining you in this part over here. Make sure you take notes. The derivative exists for each point in the domain. the graph must be a smooth line or a curve for a derivative to exist. In other words, the graph looks like a line. So let's take an example. In the previous example, what was it? Was a sine curve for us. Okay. So what was happening when we zoom in? We found when we zoom in, you go close, you will see it's like a straight line over here. Okay. So now let's see. These are the rules. The derivative fails to exist when a function has a what? Discontinuity. Number one is what? Discontinuity. If the function is discontinuous, what will happen? It will not be differentiable. So how we figure out? So let me tell you. Okay, first of all, tell me, is this function a continuous function? Yes, that's a continuous function. What happens if my function looks like this? This is a discontinuous function. So this means what? Derivative does not exist. There will be some cases which will be having a jump discontinuity. So this does not exist. Second thing is corner or cusp. Please make sure you take notes. So what is a corner or cusp? If I'm having a function like this. Now if you look at this function over here, you will say, Mr. Gupta, this is a continuous function. There is no discontinuity. Yes, but there's a cusp over here. So this point over here, this is called what? This is called cusp. So when you see these type of function, you will say the derivative does not exist, or this means there is no derivative of this function, but still it is continuous. And the third one is your what? Third one is your vertical tangent. Okay, so there will be some functions over here. See, let's take an example. You are having a function like this. Okay, so if I'm looking at this point over here, I'm just trying to find out my tangent is straight like this over here. So whenever you see a vertical straight tangent, then this means at this point you will not have any of those. There you go. At this point, let's see over here. If the function is like this and there's a vertical tangent over here, at this point, what? The function is not differentiable, or there's no derivative of this function. Let's practice some more examples. All right, this is your question number 1 over here. So let me write it over here. This is your question number 1. Make sure you copy this in your notebook because this will help you in the long run. Okay, identify points. Now do keep in mind it says point, more than one point, where the function below is not continuous. They are asking for two things: not continuous and or not differentiable. So let's start over here. Okay, so let's start with. So first of all, tell me what is happening at x equal to -3. Do you think is the function continuous over here? No. So it is not continuous and it is not differentiable also. But we'll write over here at x is equal to -3. Function is what? Function is not continuous. Okay. Let's go to the next one. What do you just give now? What happens if this is a cusp? What happens at the cusp? Now you can see the function is still continuous over here, but at this point, what? It is not differentiable because this is what? This is your cusp over here. So I'll write over here at x is equal to -2. Function is not, it is not differentiable, but it is continuous. You know this. Function is not differentiable. Let's keep going over here. I will keep going over here. What is happening at this point over here? Okay, at this point it is continuous. We don't know why it's over here. Let's keep going. What about this point? It is a cusp. Again, at x equal to 2, it is not differentiable. At x equal to 2, function is, now I will write in the abbreviated form over here. It is not differentiable. There you go. You can write it like this. Now I will keep on going over. Now you see at this point it is not continuous. You see at this point it is not continuous and it is not differentiable. I'll write over here at x equal to 4, function is not continuous. There you go. So go ahead and copy these in your notebook and make sure to draw the diagram also. After this, we'll practice next question. All right, our question number 2 says we have to find the answer whether it's true or false. Differentiability implies continuity, whether it's true or false, and continuity implies differentiability. Let's see this. Let's see this question over here. What we did just now. It will be easy for us to find the answer also from this example. Okay. All right. So let's talk about this. If the function is differentiable, it means what? It is continuous also. Let's see over here. It says at x equal to -2, x equal to -2, function is not differentiable. but the thing is it is continuous also. Am I right? So this is what? This is your true over here. What is this? This is your true. Now how does it mean? It means what? If the look over here, if I'm having a function like this, this is differentiable, and this is what? This is continuous also. This is what? True. What about this? Continuity implies differentiation, differentiability. Now when you look at this cusp over here, do you think at this point the function is continuous? Yes. But was it was it differentiable, or at this point? No, because our rule says whenever it's a cusp, the function, even it might be continuous, it is not differentiable. So this is the answer over here for this one. Okay, so there's something over here. Okay, let's practice one more question. This is a question number 3. Question says identify any x values of the function that are not continuous. Let's focus on not continuous and not differentiable. So this section says x values where the function is not continuous. So let's go over here. I will start from here, here. I'm talking about continuous. This is continuous. At this point there's a hole over here. So add x equal to 0. At x equal to 0, it is not continuous. Keep going. Okay, at this point you see there's a jump discontinuity over here. So we'll write what? At x equal to 0 and x equal to 1, function is what? Not continuous. Function is not continuous. Now let's go to another one over here. It's a differentiable. So what do you see at this point? At this point this is a cusp over here. So this means what? X equal to -2. It is continuous, but it is not differentiable. To keep in mind, it is continuous, but it is not differentiable. Let's keep going over here. Okay, what happens over here at this? Okay, what about at this point? Again, this is a corner over here. You see, this is a corner over here. So this means at this point, x equal to 3, function is what? You can see it is continuous, but it is not differentiable over here. So this means at x equal to -2 and x equal to 3, function is continuous but not differentiable. Alright, that's it for this.